Hello everyone! It's time to understand multiple linear regression in a simple and visual way. We'll focus on understanding why the model works using geometry instead of only formulas.
Multiple linear regression is a method we use when we want to predict something based on two or more factors. For example, predicting exam scores using study hours and attendance. The model tries to find the best possible fit that explains how these factors connect to the result. Now, instead of thinking of numbers in a table, imagine every variable as a direction or a vector in space. The predictors form a plane. Our goal is to express the output vector as something that lies in that plane.
The model tries to express the result vector, like exam scores, using the predictor vectors. But sometimes, the result does not lie exactly in that subspace. So, we find the closest possible representation of it. Now, imagine shining a light. The shadow that falls on a flat surface is the closest version of the object to that surface. That shadow is our prediction, which we call y-hat. The difference between the actual data and the prediction is what we call the residual error.
If we want to predict a student's exam score using study hours and attendance, regression finds how much each factor contributes. In our example, study hours had the stronger effect. So, as the study hours increase, the predicted scores also increases.
In car pricing, as mileage increases and the car gets older, the price goes down. This creates a downward sloping plane in our model.
In budgeting, more materials and more labor make the cost rise, but longer production time can reduce efficiency. The model helps companies balance resources wisely.
Now, let's look at common issues in regression when two predictors are too similar. A perfect example from our paper is predicting house prices using both floor area and number of rooms. In reality, these two are often closely linked. Bigger houses tend to have more rooms. When this happens, the vectors for these predictors in our vector space point in almost the same direction. They don't span a wide, stable plane but instead form a very narrow, almost line-like subspace. These overlaps make it difficult for the model to distinguish the individual effect of each variable. Is the price going up because of the area or because of the number of the rooms? The model can't tell us clearly. This problem is known as multicollinearity. The vector view helps us to visualize this instability when predictors overlap. The regression plane becomes very sensitive to small changes and changes in the data. So, to bring it all together, the fundamental idea we want you to remember is this. Multilinear regression works by finding the closest point in the predictor subspace to our actual data vector. This is the geometric essence of the method. We call this closest point to the projection, and the method for finding it is known as the least square solution. That's why we call it the best fit model. It's literally the closest possible representation of our outcome using the predictors we have.
To conclude, this study showed that multiple linear regression is not just a formula used in statistics, but also a geometric process that happens in a vector space. When we perform regression, we are really projecting the response vector onto the subspace spanned by the predictor variables. This helps us see how the predictors work together to produce the best possible estimate of the outcome. By understanding regression in this geometric way, the model becomes easier to interpret. We can see how each variable contributes and why problems like multicollinearity make the regression plane unstable. This reminds us that choosing our predictors carefully is just as important as doing the calculations. Overall, viewing MLR through vector spaces connect mathematics and real-world reasoning. It shows that data is not just numbers, it has structure, direction, and meaning.
Remember that mathematics is not just about solving equations, it is about understanding relationships.
And with that, we hope that this perspective gives you a deeper and clearer view of how multiple linear regression works, both mathematically and in real life applications.
Here's a QR code that you can scan for you to have access to the whole paper of this presentation. Hope this helps! Thank you for listening. Hope you've learned something new today. But hep hep hep, here are the members of this group. We have Bernardo Roswell Cody P, Mendoza Juliana Polina R, Morales Ara Jean DR, Natividad Leonard O, and No Danny R. That's all. Thank you.